Hello everyone. Today we are going to discuss about diode. So what is diode? Diode is the semiconductor material, and it is the basic semiconductor material. When we are studying about electronics, we must know what is diode. So diode is the semiconductor material that is made when the p type of semiconductor and the n type of semiconductor is joined together, we get a simple diode. So basically, diode has two terminals, and it is a two layer device. It has one junction. When p type and n type are joined together, we got one junction that is called pn junction, and it is the reason the diode is also called pn junction diode. If we talk about the working of the diode, since diode is a two-terminal device, it has P side and N side. And if we want to know how does it work, it works it has basically two modes. One is forward bias mode, and the other one is reverse bias mode. So it has two terminals. One is P side, and other one is N side. When the is p side is also called as anode. When the p side is connected to the positive side of the voltage supply, and n side is connected to the negative side of the voltage supply, this arrangement, you can say this connection, is called the forward bias connection. And basically the diode works in the forward bias connection, most of the diodes, but in also in reverse bias mode also some diode works, like Zener diodes and other diode also. But today we are going to discuss about how the diode operates in the forward bias mode. Okay, so when we are connecting the positive side of the terminal of the when we are connecting the positive side of the terminal with the p side, and the negative side of the terminal with the n side of the diode, we are getting the diode is forward bias. And there is a concept that when it will not just start, it is forward bias, it will conduct, but it will conduct when it is getting a minimum voltage supply, means and that is called the cut-in voltage, or you can say the knee voltage. Diode requires a minimum amount of voltage to turn on, or to work in a forward biased mode. So that voltage is called cut-in voltage or forward bias voltage. Cut-in voltage or knee voltage, yes. So like for and it is different for and it depends on the kind of material that we are using for making the diode. Like for example, if it is silicon diode, then it takes a zero point 0.7 volt. That is the 0.7 volt is the minimum um, cut-in voltage or knee voltage for the silicon diode to conduct in the forward bias. And for germanium, it is 0.3 volt. 0.3 volt is the cut-in voltage for germanium. And for other diode, and it depends on the kind of the material that is being used in making the diode. So when the diode is in forward bias, as we have applied the uh, voltage, so what happened, the p side is connected to the positive terminal, and the n side is connected to the negative terminal. So the electron from the n side and the holes from the p side are attracted towards each other, and they comes to they comes closer to the depletion reason, or you can say it comes to closer to the junction. And they began to, and if we are increasing the voltage supply, then the electrons from the N side and the holes from the P side, they begin to combine each other. And when they combine each other, the depletion layer is formed, and due to the diffusion, the potential difference is formed in the depletion region, and that potential difference is called the built-in potential or contact potential. The potential difference that is formed due to the diffusion of the electron from the N side and the holes from the P side in the junction. So this forms the potential difference, that is the contact potential, or you can say the built-in potential of the diode. Now, take for example, now if we are like we are connecting the positive I mean we are connecting the p type p side or anode of the diode with the nth negative terminal, and the N side of the diode with the positive terminal. What happened? The electrons are attracted towards the negative terminal. The electrons are attracted towards the positive terminal. Okay, and from the P side, the holes are attracted towards the negative terminal. So this result in the expansion of the depletion region, and as the depletion region is expanding, the capacitance of the depletion region is decreasing. As we know, like capacitance is directly proportional to the area, and inversely proportional to the distance, that is c is equal to epsilon a by d. So you can relate that as the depletion region is, as we are increasing the reverse bias voltage, the depletion region began to expand. And we know the depletion region is that region where the mobile carriers are depleted. Okay, so this is the reason, so where the mobile carriers are less or depleted. So the depletion region, the area, it acts like an insulator, and the P side and the N side material, it acts like the conductor. So basically it is making a capacitance. So we can say this is a junction capacitance. So junction capacitance is also divided into two parts, two types. One is diffusion capacitance, and the another one is depletion capacitance. As the name suggests, diffusion capacitance is made when the diode is forward biased, and diffusion means the electron from the N side and the holes from the P side, they are beginning to diffuse. And if when the diode is in forward bias, they will come closer and for the diffusion, and when they are coming and making it still a very narrow junction. So what is the case in that case? The energy stored, you can say, it is more, the capacitance is more. This is you can say it is also called storage capacitance or diffusion capacitance. And it is in the case when the diode is forward biased, and the electrons and holes, they tend to diffuse to each other. And the another one is the depletion capacitance. As we are discussing, that depletion capacitance occur when the diode is in reverse bias. And when the diode is in reverse bias, as we're increasing the reverse bias voltage, the depletion region is expanding. And when it is expanding, we know that there is the depletion of the mobile carrier, and when they are and it acts like an insulator. So basically this is the capacitor, and with the increase in the distance between them and also the area is also increasing, so it is the capacitance of the depletion reason is decreasing. So we can say the capacitance of the junction capacitance, or transitional, it is also called the depletion capacitance is also called the transitional capacitance, it is less. Okay, so it is less. So this is the junction capacitance what we were discussing. Now we were saying that when the diode uh, is applied the voltage above the knee voltage or the cutting voltage, it began to conduct. So when the diode is conducting, there we can see that there is the sudden rise in the current, there is the exponential rise in the current when it crosses when a particular voltage, a knee voltage is applied to the diode. So that is we can say it is denoted as I is equal to is, and in the bracket e to the power v naught by n vt minus 1. So here v is the supply voltage and vt is the thermal voltage that is 25 to 26 millivolt. And here eta is the you can say it is the ideality factor, and it is basically 1 or 2. And here is the you can say it is the reverse saturation current. So what is reverse saturation current? As the name suggests, reverse saturation current is that current uh, which uh, which is due to the flow of the minority carrier. When the when the diode is in reverse bias, the flow of the current due to the minority carrier is the reverse current. And now let us talk about the application of the diode. So basically the most basic you can say the application of the diode we can see as a rectifier. What is rectifier? We have a lot of rectifier is there, like full wave rectifier, half wave rectifier, bridge rectifier. So basically rectifier is the device that can change the AC into DC, AC into DC. And also we can say like in our home we LED. This is the application of the diode, and then voltage regulators and many more. And thank you so much for listening to me, and that's all for today. Thank you. Bye bye.